Good morning, everybody. I'm Janvi and I'm going to give a seminar on the topic Avalanche. So, what is Avalanche? According to the official website, Avalanche is a blazingly fast, low cost, and eco friendly platform. Avalanche is an open source platform for launching decentralized applications and enterprise blockchain deployments in one interoperable, highly scalable ecosystem. It is a part of the Internet of Assets, which is a global financial network for issuing and trading all digital goods. It is a layer 1 smart contract platform built by Ava Labs. It is a proprietary proof of stake blockchain that is Ethereum compatible and environment friendly. The Avalanche blockchain is already low on carbon emissions, yet it took the step of becoming a net zero technology, which refers to achieving an overall balance between greenhouse gas emissions produced and greenhouse gas emissions taken out of the atmosphere. Avalanche was originally named Avalanche Borealis on its initial release. Most things in the Avalanche universe are named with a reference to snow, such as Snowman, Snowflake, Slush, and many more. The Avalanche blockchain mainnet was launched in September 2020 by the Ava Labs team in US. The three-person team behind the Ava Labs consists of Kevin Seknicki, Marfan Tedian, and Emin Gunsirer. The protocol was created by a pseudonymous team of developers known as the Rocket. Powered by its native token AVAX, Avalanche uses multiple consensus mechanisms. Avalanche claims to be the fastest smart contracts platform in the blockchain industry as measured by time to finality. It also claims to be the third family of protocol which is leaderless in nature and call themselves metastable, which means all nodes in a network come to the same conclusion in a consensus in deciding what is wrong and what is right using probability. They take the guarantee that the outcome is reaching consensus eventually. AVAX is the native token of Avalanche. It's a hard-capped, scarce asset that is used to pay for fees, secure the platform through staking, and provide a basic unit of account between the multiple subnets created on Avalanche. Developers can also issue their own tokens on its custom blockchains. The maximum supply of AVAX is 720 million tokens, half of which were created with the Genesis block or the first block. Similar to Ethereum network, fees in Avalanche are burnt, progressively deflating the token supply. As a proof of stake platform, Avalanche relies on validators that stake AVAX to earn block rewards. This consensus protocol family consists of four protocols: Slush, Snowflake, Snowball, and Avalanche. It is metaphorically beautiful in a sense that it starts with a non-Byzantine protocol Slush and progressively builds up Snowflake, Snowball, and Avalanche, all based on the same common metastable mechanism. To begin with, Slush is the foundation of this protocol family. It is a single degree consensus protocol that is inspired by the gossip or epidemic algorithms. The main idea of Slush is to categorize all nodes with high probability in an identical manner. Slush is not tolerant to Byzantine faults but serves as an illustration to the other algorithms that are built on it. I'll explain how Slush works with an example. In this case, let us consider an actually fraudulent transaction. Here, we have 20 nodes, 16 of which think that the transaction is actually fraudulent. 4 of them think that the transaction is genuine. Each node decides whether the transaction is to be accepted or rejected. It is only a preference and is not the final decision. To reach a conclusion, each node asks a sample of 5 random colleagues what they think of the preferences. In this case, node 1 asks node 6, 12, 9, 10, and 15. The majority of nodes from the sample would decline the transaction. As a result, node 1 would change its mind. It joins the majority and also rejects the transaction. This way, every single node consults with its colleagues and eventually adjusts to the primary preference. All nodes come to the agreement that the transaction needs to be rejected. Sometimes a node may consult its colleagues several times, performing the same action over and over again until everyone has the same opinion. But what if, after each node consulted with its colleagues several times, there are still some malicious nodes, in which case honest nodes wouldn't be able to reach agreement on whether to accept or reject the transaction? This endless loop is broken by Snowflake, an improvised version of Slush. The purpose of Snowflake is to strengthen Slush with a single counter that emphasizes the node's loyalty on its current decision. This per node counter stores how many consecutive samples of the network have all yielded the same decision. A node accepts the current decision when its counter exceeds beta, a security parameter. Each node maintains a counter. Upon every successful query, the node increments the counter. The counter resets to 0 whenever it changes its decision. Continuing with the previous example, now using Snowflake protocol, since each node is equipped with a counter, it keeps track of how many rounds of consultations in a row gave the same result. If the streak is broken, the counter sets to 0 and starts again. For example, after a node asks 10 random groups of colleagues and in every single round it gets the same response, it is sure of the response. All honest nodes will eventually come to the same conclusion. What if a node gets the same response to reject a transaction 9 times in a row, and in the last query, a group of malicious nodes somehow manage to overrule it? Now, since the threshold of 10 is not met, the node which asked would be misled and the counter reset. This can be problematic as it delays the transaction verification process. This is where Snowball comes in. Snowball augments Snowflake with confidence counters that capture the number of queries that have yielded a threshold result for the corresponding decision. A node finalizes its decision if during a certain number of consecutive queries, its confidence for that decision exceeds that of other decisions. Upon every successful query, the node increments its confidence counter for that decision. Snowball is not only harder to attack than Snowflake, but is more easily generalized to multi-decree protocols. In a nutshell, Snowball adds a layer of protection by implementing confidence counters. Avalanche, the final protocol, generalizes Snowball and maintains a dynamic append-only directed acyclic graph of all the transactions. This is done to improve efficiency and security. Protocols in the Avalanche family operate through a process called repeated random subsampling or repeated subsampled voting. When a validator is determining whether a transaction should be accepted or rejected, a small random subset of validators is asked whether they think the transaction should be accepted or rejected. If the queried validator thinks the transaction is invalid or has already rejected the transaction or prefers a conflicting transaction, it replies that it thinks the transaction should be rejected. Otherwise, it replies that it thinks the transaction should be accepted. If a sufficiently large portion of the validators sampled reply that they think the transaction should be accepted, the validator prefers to accept the transaction. That is, when it is queried about the transaction in the future, it will reply that it thinks the transaction should be accepted. Similarly, the validator will prefer to reject the transaction if a sufficiently large portion of the validators replies that they think the transaction should be rejected. The validator repeats this sampling process until a majority of the validators queried reply whether they accept or reject the transaction for a given number of consecutive rounds. In the common case, when a transaction has no conflicts, finalization happens very quickly. When conflicts exist, honest validators quickly cluster around conflicting transactions, entering a positive feedback loop until all correct validators prefer that transaction. This leads to the acceptance of non-conflicting transactions and the rejection of conflicting transactions. So what is a DAG? A DAG is like a database that connects different pieces of information together. Conceptually, DAGs are made up of vertices and edges. Breaking down the term directed acyclic graph, they're directed because they head in one direction, and they're acyclic because they don't loop back on themselves. If you start at one point and follow the graph, you can't return to that same point again. Why DAG? Avalanche makes use of DAG to overcome certain drawbacks of blockchain, one of which is low throughput. When there are more transactions than the space available in a block, one needs to wait for the next block. This can be thought of as a situation where you have to wait for the next bus because the current bus has too many people. The second drawback is wasted resources. If two blocks happen to be created at the same time, they can continue to grow for some time simultaneously until eventually participants shift towards one chain. In this case, all the transactions from the eliminated chain need to be processed again, meaning all the resources that are put into this chain are wasted. Avalanche solves these problems by making use of a tag. It makes voting more efficient as a vote for one transaction is a vote for all transactions it is appended to. This also means that it is harder to undo past decisions. The network speeds up as more transactions are added because every time a new transaction is added, two older transactions get validated and approved by the network. DAGs also do not use as much data as the blockchain network since all you need is a fraction of all the transactions. In theory, DAGs are a lightweight system that is quick when it comes to processing transactions. This makes it extremely scalable, at least as compared to blockchain. Avalanche architecture consists of four key components: the virtual machines, subnets, chains, and consensus engine. Snow protocols form the basis for Avalanche consensus. The platform has two consensus engines: Avalanche, a DAG optimized consensus with high throughput that is parallelizable and simple to prune; Snowman, a chain optimized consensus with high throughput that is totally ordered and best for smart contracts. The Snowman consensus protocol builds on the Avalanche consensus protocol but orders transactions linearly. This property is beneficial when dealing with smart contracts. Unlike the Avalanche consensus protocol, Snowman creates blocks. On Avalanche, you launch a decentralized application as a virtual machine instead of a smart contract. A virtual machine defines the application level logic of a blockchain. In technical terms, it specifies the blockchain state transition function, transactions, and the API through which the user interacts with the blockchain. Every blockchain in Avalanche is an instance of a virtual machine. In Avalanche, these are like code that use consensus to produce a database. This database can be in the form of a DAG, a chain, a log file, or some other data structure that requires synchronization across multiple devices. When a developer writes a machine code, they need not concern themselves with the lower level logic like networking, the consensus protocol, and the structure of the blockchain. Avalanche does all of that behind the scenes so that the developer can focus on what he'd like to build. Avalanche Virtual Machine makes it easy to define a blockchain-based decentralized application. The virtual machine logic can be deployed many times across many subnets. The Avalanche virtual machine uses elliptic curve cryptography for its signatures on the blockchain. Avalanche features three built-in interoperable blockchains: the exchange chain for transfers, the platform chain for staking, and the contract chain for decentralized finance. By splitting its architecture across three separate blockchains, Avalanche is able to optimize for flexibility, speed, and security without any trade-offs. This makes it a powerful platform for both public and enterprise use cases since developers have a great deal on flexibility in the types of applications they can build. All three blockchains are validated and secured by the primary network. The primary network is the special subnet, and all members of all custom blockchains must also be a member of the primary network by staking at least 20,000 AVAX. A subnetwork is a dynamic set of validators working together to achieve consensus on the state of a set of blockchains. Each blockchain is validated by exactly one subnet. A subnet can validate many blockchains. A node may be a member of many subnets. A subnet manages its own membership, and it may require that its constituent validators have certain properties. A blockchain can be validated by only one subnet, but each subnet can validate multiple blockchains. Avalanche Subnet Architecture makes regulatory compliance manageable, which means that a subnet may require validators to meet a set of requirements. The exchange acts as a decentralized platform for creating and trading digital smart assets. One asset traded on the exchange is AVAX. The exchange is an instance of the Avalanche virtual machine. The exchange API allows clients to create and trade assets on the exchange and other instances of the Avalanche virtual machine. This chain is used for creating and exchanging AVAX tokens and other digital assets. These assets have modifiable rules that govern the behavior just like Ethereum's token standards. NFTs are directly integrated into the exchange transaction structure. The P-chain is the metadata blockchain on Avalanche that implements the Snowman consensus protocol. It coordinates validators, keeps track of active subnets, and enables the creation of new subnets. It is the only default subnet on Avalanche platform that is permissionless. The C-chain is where developers can create smart contracts for the decentralized applications using the C-chain's API. It is an instance of the Ethereum virtual machine, thus enabling coders to fork over EVM compatible decentralized applications. It makes use of the Snowman consensus protocol. What is Athereum? Athereum is an Avalanche-based testnet on Ava, one of the so-called Blockchain 3.0 networks. Athereum is the first subnet supported on the Avalanche platform, integrating an existing virtual asset. Ethereum possesses the entire functionality built into the Ethereum virtual machine. In lieu of the ETH token, the native token supported on the Ethereum platform is ETH. According to its official website, Athereum is a spoon or friendly fork of the Ethereum, which benefits from the Avalanche consensus protocol and applications in the Ethereum ecosystem. Athereum is 100% Ethereum running on the Avalanche technology. It boasts of a throughput as high as the Ethereum virtual machine allows. Instead of longest chain proof of work, Ethereum uses a staking-based linear chain version of the Avalanche protocol. The AVAX token has a hard supply cap of 720 million. Transaction fees across the mainnet, fees for creating and minting assets, and fees for creation of blockchains and subnets are all paid in AVAX, which are burned afterwards. This scarcity makes the token deflationary. The token distribution is shown here. The first 360 million AVAX were issued upon launch, with the remaining 360 million distributed over decades. An Avalanche native token is a fixed cap or variable cap token created on the exchange. These tokens can be exchanged at lightning fast speeds on the exchange. Avalanche native tokens do not include non-fungible tokens created on the exchange. Avalanche has grown tremendously since its inception and has been competing with other prominent cryptos like Solana, Polkadot, Bitcoin, and Ethereum. No doubt, it has been called a potential Ethereum killer. Some of the cons of Avalanche include too much staking and not enough liquidity. Avalanche, from inception to now, has had a ratio of about 70 to 80% of all coins being staked. This means that early comers have a very strong hold on the project. Avalanche has had relatively high and unpredictable transaction fees. There are fears of centralization of Avalanche around Ava Labs, since Ava Labs controls over half of the online stake. Avalanche is the best verifiable platform for institutions, enterprises, and governments to launch assets, build applications, and create subnets with complete control over implementation with compliance, data security, and other rule sets built into the foundation. Decentralized finance projects such as SushiSwap, Chainlink, and protocols such as Curve have used Avalanche. Tops recently launched NFTs on Avalanche. Also, Pangolin, a community-driven decentralized exchange platform, is supported by the Ava Labs. Pangolin is a key part of Avalanche's decentralized finance ecosystem and is built to demonstrate the capabilities of the Avalanche platform. Thank you for your attention.